Notes number 2, solving absolute value equations, part 1. Objective, I will be able to graph the solution set for a linear inequality, and I will also be able to represent the solution using interval notation. Notebook setup, we have 6 boxes today. Let's go on to the first box. Interval notation, so this is a definition. Interval notation is a way to write the solution to an inequality using infinity symbols. Just in case you've never seen the infinity symbols, this is a positive infinity and this is a negative infinity. Parentheses, and brackets. Okay, so parentheses indicate not included or open. So anytime you see parentheses around a number, it represents that it is excluding that number. And anytime you see brackets, it indicates included or closed. That means that number is a solution to that equation, or in this case, inequality. Okay. Set notation is another way of expressing the solution to an inequality. For example, x is greater than 3. Okay, set notation, rewrite it in the form that we have here on the right hand side, and that reads as, and I'll highlight so you know the parts, the set of x values where x is greater than, in this case, 3. Okay, so notice how that blue represents what's highlighted in the set notation. Of course, the green is your x value, the inequality is greater than, and the yellow, which represents the number 3. Okay, so let's go on to the first example. In this first example, notice that on the left hand side we have some shaded red, and on the right hand side we also have more red. So we're going to go ahead and write our set notation. Our set notation, we start off as the set of x values. So that is my x values, right? Where x is less than -4. This right here, this right here represents the left hand side. If you notice, that arrow is continuing towards the left, so that includes -5, -6, -7, -8, -9. Notice that it's an open circle, and because it's an open circle, we have a less than only. We don't include the equal sign. And on the right hand side we have or x is greater than or equal to 2, and that is the left hand side of my inequality. That's this side right here. And in this case we do have we do include the equal sign because it is a closed circle. That means that 2 is a solution, but -4 is not. Okay, so this would be my my set notation, sorry. My interval notation, basically what I'm going to do is I'm going to use infinity symbols, parentheses, and brackets when needed. So I start off with the left hand side, which indicates negative infinity. That goes on to -7, -8, -9, -10, and so on and so forth, comma, -4. Because a -4 is an open circle, I use a parentheses. That means -4 is not a solution to this inequality. Union 2, comma, positive infinity, and close parentheses. Notice that I haven't put a bracket or a parentheses next to the 2 because the 2 is a closed circle. We use a bracket. That means 2 is a solution to my inequality. example 2. In this case, we have the shaded region in between the two numbers, so the two given numbers, which is -3 and +5. So for this one, our solution set is still going to be the x values, the set of x values where x is, where -3 is less than or equal to x and less than 5. For my interval notation, I start off with -3, comma 5. This one's a little bit easier when you note it, when you have your shaded region in between. So if you notice, my answer is in between my two points. So on the left hand side we have a bracket because it includes the 3, and on the right hand side we have a parenthesis because it's an open circle, so it excludes the 5. All right. I usually like to tell my students, we call this an and statement. And the reason I remind students it's called an and statement is because notice my sentence, the solution is between -3 and +5. Let's go example number 3. And this time we're actually going to go ahead and solve for v. All right, so first step we're going to do is take away or subtract 5v on both sides of the inequality. We have 1 is greater than 2v minus 17. Going to go ahead and add 17 to both sides. And I have 18 is greater than 2v. Divide both sides by 2. And I get 9 is greater than v, or I can rewrite it as v is less than 9. Now, for me, I need a visual representation, so I'm going to go ahead and draw my number line. I have 9, 10, 11, 12, 8, 7, 6 on the left hand side. This one's going to be open circle. And in case you're wondering why it's an open circle, is because it doesn't include, does not include the equal sign as part of my inequality. And it says that v is less than 9, and less would be on the left hand side. And it continues, the shading continues on forever. Now I'm going to go ahead and write my set notation, right? So I have the set of x values where x is less than 9. Okay. Actually, and in this case, because we're using the variable v, I should be writing it the set of v values where v is less than 9. So I do apologize for that. Just used to using x. Interval notation. Interval notation, we have -infinity, comma, +9. Parentheses around the infinity, and because the 9 is an open circle, we go ahead and put a parenthesis. And one last piece of information. This is important information that we normally forget. It says anytime you multiply or divide by a negative, you must reverse the inequality. Very important that we remember this, because depending on the inequality that you're solving and how you're solving it, you might have to reverse the inequality symbol. And what I'll do real quick, I will show you using the example 3 that we just completed. So here on the side I have 5v plus 1 is greater than 7v minus 17. So I'm going to solve this problem, and I'm going to solve it using different steps, but at the end I should still get the same solution, which was 9 is greater than v, or v is less than 9. So going to go ahead and subtract 7b on both sides, subtract 7b, and I get negative 2v plus 1 is greater than negative 17. Next, I'm going to subtract 1 on both sides, subtract 1 on both sides, and I get negative 2v is greater than negative 18. And then divide both sides by negative 2 and negative 2. And this is what we mean by this rule. Anytime you divide or multiply by a negative, right, those inequalities must flip. So we end up with b is less than 9. Okay, so I'll kind of highlight it so you ladies and gentlemen have a reference. But that's what this rule says. Notes number 3, linear inequalities and interval notations, part 2. Set up your notebook. We'll be doing 4 examples. Okay, example 4. This is continuing from our notes number 3, so we'll continue with the example number. So we have example 4. Our goal is to solve for r. Once we solve for r, we want to write our solution in set and interval notation. So the first thing I would do here is to try and get rid of the fractions by looking for the lowest common denominator, LCD. In this case, it's 15. So I'm going to multiply by 15 in order to get rid of the fractions. So if you notice, I can actually simplify this one, and I'm just going to go ahead and distribute 3. The denominator becomes 1. So I have a numerator of 6r minus 9. Second set of parentheses, I can simplify this, and that becomes 5. So I'm going to distribute the minus 5. So I end up with minus 5r plus 15 is less than or equal to 30. Now I'm going to go ahead and combine like terms and combine the r's, and that just gave me 1r or r. Combine the integers, which I have negative 9 and positive 15, and that gives me positive 6 is less than or equal to 30. Subtract 6 on both sides, and I get r is less than or equal to 24. Now my set notation, I have the set of r values where r is less than or equal to 24. Okay, then the second one, my interval notation, I have, in this case, if you ladies and gentlemen notice, r is less than or equal to 24. That means that negative infinity comma positive 24. The reason I have negative infinity is because my solutions are 23, 22, 20, 21, 20, and so on and so forth, all the way to the negative side of my number line. Negative infinity has a parenthesis. In this case, we have also the equal part of it. If you notice right here, equal. So it is a bracket on the right hand side. Example 5. We're going to go ahead and simplify by distributing both sides. So I'm going to distribute the 3. And I have 24x minus 27 is greater than 24x plus 4. Subtract 24x on both sides. Subtract 24x. So I have negative 27 is greater than 4. Now, although my x values have canceled out, we still have to look at this statement and determine if this statement is true or false. Is negative 27 greater than 4? And in this case, this statement is false. Because the statement is false, this would be a no solution inequality. All right, let's go on to example 6. Example 6, same thing as example 4, we want to get rid of the fractions. So what I'm going to do is I'm going to multiply the left hand side by negative 2 and the right hand side by negative 2. On the left hand side, the negative 2's cancel out. So I have 4 plus 5 parentheses 2w minus 10 is greater than negative 2w minus 14. Going to go ahead and distribute the 5. All right, so I have 4 plus 10w minus 50 is greater than negative 2w minus 14. On the left hand side, I can combine like terms by combining the 4 and the negative 50. So I have 10w minus 46 is greater than negative 2w minus 14. Going to add 2w to both sides. And I have 12w minus 46 is greater than negative 14. Add 46 to both sides. And I have 12w is greater than 32. Divide both sides by 12. And I end up with w is greater than 32 over 12. And I can simplify that fraction by 4. And I get w is greater than 8 over 3. My set notation, I have the set of w values where w is greater than 8 over 3. Interval notation, I have 8 over 3 comma positive infinity, and I have parentheses around both of them because 8 over 3 doesn't have the equal sign. Sorry, because this inequality doesn't have the equal sign, I do not include bracket. That means 8 over 3 is excluded from my solution. Okay. And let's go to example 7 now. I'm going to go ahead and distribute the negative. Distribute the negative on the right hand side. So I have 11x minus 4 is less than or equal to 6x minus 3 plus 5x. On the right hand side, sorry, I can combine like terms, and I have 11x minus 4 is less than or equal to 11x minus 3. Subtract 11x on both sides, and I have negative 4 is less than or equal to negative 3. Now, same thing as example number 4, we want to look at, sorry, example number 5, we want to look at the solution. Is this statement right here true, or is this statement false? In this case, this statement is true. And because this statement is true, our solution is all real numbers. So our solution is going to be in set notation written as the set of x values where negative infinity is less than x less than positive infinity. In other words, this means that any value that we choose on our number line is a solution to this inequality. In interval notation, we have negative infinity comma positive infinity, and it represents the same thing. So any value that I choose as my x value will make this inequality a true statement.